Good evening, everyone. In the previous class, we have learned about different errors in chain survey. When the chain is too short, there may be an error in the final result. At the same time, when the chain is too large than the standard length, we will encounter errors in the measured lengths. So in this class, we will cover some of the problems related to the calculation of true length of the survey line as well as true areas. We will learn some of the problems regarding calculation of true lengths, true areas, and true volumes when the boundary given is measured with the help of incorrect chain. The first problem is the length of survey line measured with 20-meter chain was found to be 635.4 meters. When the chain was compared with standard chain, it was 0.2 meter too short. Find the true length of the line. As the length of the chain is too short, we will get the more value than the actual value of actual means true length of the line. So here we have to calculate the correct length of the chain as the measured length is more than the actual length. So you know the formula for true distance, which is incorrect length of the chain by correct length of the chain into measured length. Whereas incorrect length is L dash. L dash means in the problem he is telling that it is 0.2 meters short, which means it is actually 19.8 meters. The correct length of the chain is 20 meters. Measured length is 635.4 meters. If we substitute all these values, we will get true distance 629.046 meters, which is lesser than the measured length. We will see what is the necessity of correction. In view of various errors that are likely to occur, appropriate corrections are to be applied. Why we will apply correction means to nullify their effects to get high degree of precision. This is our aim in calculating lengths and areas. The tape or chain length is standardized under certain conditions of temperature and pull and sag, etc. But it can never be practically used in the field under specified standard conditions, because some people may apply a different pull which is not equal to the standard pull. And the temperature conditions are also varies in the field, which is not at that time, it is not the standard temperature. So we have to consider these conditions to get the more accurate result. But it can never be practically used in the field means the same pull, the same temperature may not be possible in the standard specified conditions. So it becomes necessary to apply the corrections to get the true lengths. Let us see what are the different corrections in chain and tape. We have correction for absolute length, correction for slopes, corrections for temperature, corrections for sag, corrections for pull. So we have these different corrections which are to be applied in measured lengths to get the accurate results. But we shall limit our discussion only to correction due to incorrect length or tape. Correction for absolute length. The actual length of the tape during measurement may not be equal to the standard design length. The distance measured may be too large or too small. Accordingly, the correction may be applied. We have already calculated correction for incorrect length, which is L dash by L into measured length. This L dash is the incorrect length of the chain and L is the correct length of the standard length of the chain. Similarly, we have already learned this formula for calculating true area, which is L dash by L whole square into measured area, where L dash represents incorrect length of the chain. It may be too short or too long. L is actual length, means correct length. and correction for volume is L dash by L whole cube into measured volume. For better understanding, we have to solve more problems in this topic so that everybody will be understanding the concept. The length of a line was found to be 600 meter when it was measured with 20-meter chain. If the chain is 15 centimeters short, find out the correct length of the line. The chain is 15 centimeter too short. It means it measures, uh, it gives more value uh, than the true length. So we have to find out the true length. Here it is telling that the chain is 15 centimeter too short, which means 0.15 meter too short. Therefore, incorrect length L dash is equal to 19.85 meters, which is 0.15 meter lesser than the standard length 20 meter. We already know the formula for true length, which is L dash by L into measured length, where L dash is 19.85, L is 20 meter, and measured length is 600 meters. Substituting these values to get the answer. So we have true length as 595.5 meters. We'll solve another model. The distance between 2 points measured with a 30-meter chain was recorded as 540 meters. It was afterwards found that the chain was 6 centimeters too long. What was the true distance between the points? There is a clear difference between the first example and the second example. In the first example, the chain shows the chain has the error right from the beginning. But here in this problem, yeah, it is also the same model. So we will solve another problem. This is also the same, which is different from the previous problem. Let us see this problem. The length of the line measured with 20-meter chain was found to be 475 meters. The length of the line was known to be 476.20 meters. Find the error in the chain. So the initial value of measured length 475 meters is not the true value because it is the chain has some error. The true length is also given as 476.20 meters. Substituting in the formula, we will get the error. We already know true length is equal to L dash by L into measured length. True length is given as 476.2 meters. Measured length is 475. L dash we have to find out. L value is 20. Here, when you find out L dash value, it is 20.05 meters, which is 0.05 meters too long than the standard. Therefore, error in the chain is 0.05 meters. In this way, we can calculate the error in the chain when measured length and the true length of the chain is given. Another problem. A line AB was measured with a chain which is found to be 150 mm too long. At the end of measuring a length of 1060 meters, what is the true length of the line if the chain used is 20 meter at the beginning of the work? So here there is a clear difference compared to the previous problems. Initially the chain is 20 meter, which is equal to the standard length, but after measuring 1060 meters, it is observed that the chain is extended by 150 mm. So we cannot directly write L dash as 20.15 meters Suppose at the initial stage it is 20 meters. In this case, we have to take the average error before starting the survey and after ending the survey. Before starting the survey, the error is 0. At the end of the survey, the error is 150 mm, which is equal to 0.15 meters long. So the average error is 0 plus 0.15 by 2, which is 0.075 meters. Therefore, the average error E is 0.075 meters too long. And the remaining calculations is very similar to the previous problem, where true length is L dash by L into measured length. L dash is 20.075 divided by 20 into measured length. So we will get the correct answer, means measure true length of the line. The only difference we have to understand and we have to identify here is the chain initially measures 20 meters. After measuring 1060 meters with this chain, it is found to have an error of 150 mm. Therefore, we have to take the average error into account in calculation of the L dash value. Average is 0.075 meters too long. So here we have to substitute at 20.075 in case of in the place of L dash. So that is what we have to remember. And we have another problem. The distance between two stations was measured, the 20-meter chain, and found to be 600 meters. The same was measured with 30-meter chain and found to be 596 meters. The 20-meter chain was 5 centimeters too short. What was the error in 30-meter chain when measured with a 20-meter chain? Here we have to understand the given two lengths, 600 meters, measured lengths, 596 meters, both are erroneous lengths. First, we have to find out the true length. After that, we have to measure the error in the required chain. So from the first statement, the measured length is 600 meters when the length of the chain is 20 meters. Here, the error we can, in the second statement, we have a measured length of 596 meters when it is measured with 30 meter chain. We will solve these two equations to get the error. True length of the line formula is L dash by L into measured length. We will substitute the first statement equations where measured length is equal to true length is equal to L dash by L into measured length, which is 19.95. We are substituting 19.95 because he is given that 20-meter chain was 5 centimeters too short. Therefore, incorrect length L dash is 19.95, standard length is 20 meters, and the measured length is 600. So here we get the true length of the line. By using true length of the line, we can measure the error in 30-meter chain. The same formula again we have to substitute to get the value. Here the measured length is 596 meters, true length is 598.5 meters. Therefore, L dash is equal to 598.5 divided by 596 into 30, which is equal to 30.126 meters, which indicates the length is 0.126 meter too long. Hence, the error in 30-meter chain is 0.126 meter. In this problem, first we have to measure the true length within first statement. By using the true length, we have to calculate the error in the 30-meter chain. This is how we have to do it. A 30-meter chain was tested before the commencement of the day's work and found to be 5 centimeters too long. After chaining a distance of 1600 meters, it was checked again and found that it is 10 centimeter too long. At the end of day's work, after chaining 3000 meters, the chain was found to be 18 centimeter too long. Find the true distance measured. This is very interesting problem where the chain measured erroneous at the beginning, in the middle, and at the end of the survey. Here we have to here we can divide the entire problem into two phases, where from starting to the intermediate point and intermediate point to the ending. The survey can be divided into two parts, starting to the intermediate point and intermediate point to the end point, where the average error in between the starting and intermediate point is 5 centimeter plus 10 centimeter divided by 2. So the error in measuring 1600 meter length is the average of 5 plus 10, which means 0.075 meters long. In the second half of the problem, the average error is 10 centimeter plus 18 centimeter divided by 2, which is equal to 14 centimeter, means 0.014 meter. By using these errors, we can calculate the true length in the first half of the survey and second half of the survey. In the first half of the survey, true length, the formula for true length is L dash by L into measured length, which we have already discussed, where L dash is the average of two errors at the starting and at the after measuring 1600 meter length, so which is 30.075. The standard length is 30 meters. The measured length is 1600 meters. Therefore, the true length is 1604 meters. In the same way, we have to measure the second half true distance. For next 1400 meters, the average error is 0.09 meters. Therefore, the incorrect length is 30.09 meters. True length is equal to 30.09 divided by 30 into measured length, which is 14.04.2 meters. 1404.2 meters. Total length of the line, which is total true length of the line, is 1604 plus 1404.2, which is equal to 3008.2 meters. Due to error in the beginning, intermediate, and last positions of the chain, it was measured 3000 meters only. After calculating the true distances, we have arrived at the true length of the line, which is equal to 3008.20 meters. So these are the different numericals which will help us to understand the calculation of true length of line or true areas of boundaries. After this, we will switch on to another topic, which is called obstacles in chain survey. We have different obstacles while doing chaining. So we have classified the total obstacles into three. The following three. The first one is chaining obstructed but vision is free. The second one, chaining is free but vision is obstructed. Both chaining and vision are obstructed. So chaining obstructed means it is not possible for Chinese. It is not possible for laying the chain, but we can see the points from one point to another. Chaining is free, vision obstructed means we can lay the chain over it, but vision is not obstructed. So there may be a possibility of hill in between 2 points where we can lay the chain, but we cannot see the points from one point to another. Both chaining and vision obstructed means, suppose if there is a building in the chaining survey, which means we neither lay the chain nor calculate, nor observe the points from each other. So these are the examples. We will discuss one after another. Chaining is obstructed but vision is remains. There is an example like pond and river, where we can observe two different points on the river, two different points on either sides of the river, but we cannot do chaining operation. Chaining is free, but vision is obstructed. Means suppose if there is a high level ground or a hill in between 2 points, we can lay the chain on the hill, but the vision is obstructed. Both chaining and vision are obstructed. Means suppose if there is a building, we cannot see 2 points on either side of building, one point or another. At the same time, chaining is also obstructed. Chaining is obstructed, but vision is free. This is the case when a pond or river or plantation intervenes. Two convenient points have to be located on a chain line on either side of obstacle for finding the chain length. The distance between them is measured. We have two cases here. Case one is it is possible to chain round the obstacle. Example, for if there is a pond or river, then we can do the chaining operation around the obstacle. Sometimes it is not possible to chain around the obstacle, something like a river. In these two cases, we have to measure the length of the required length. Let us discuss the first case, when it is possible to chain around the obstacle. In figure 1, we can observe that there is a pond where there is a possibility that we can measure around the obstacle. Suppose, let us say AB is the distance which we have to measure. We can measure like the following precision. First, lay the chain from A to P. If P is a point which is nearer to the pond, then erect a perpendicular at point P so that it crosses the obstacle and mark the point R. At R again, we have to erect another perpendicular to the line RP until the obstacle crosses, and we'll note down another point S. 2 points PQ are selected on the same line on either side of obstacle. These are 2 points. Equal perpendiculars PQ, PR and QS are erected at P and Q. Here a perpendicular is erected and here also perpendicular. So RS is the distance which represents PQ. So here directly we can measure the obstructed distance PQ by erecting 2 perpendiculars at P and Q. Therefore, PQ is nothing but RS. We have another method. A perpendicular PR is erected at a point P such that Q can be chained from R. The distance PR and PQ is given by PQ is equal to PR square plus RQ square, which is given by Pythagoras theorem. This is also another method of calculating the obstructed length. Here simply we have to erect a perpendicular and draw a line which touches a point which is on either other side of the point. So this is a rectangle triangle. By using this rectangle triangle, we can find out the obstructed length. We have another method, method 3, the crosstalk or optical square. Here the obstructed length is PQ. Find a point R which makes 90 degrees with P and Q. Measure PR and QR. Now the distance PQ square is equal to PR square and QR square. Again, it measures 90 degrees here, means it is a right angle triangle. So this is hypotenuse. Hypotenuse is PQ square is equal to PR square plus QR square. This is another method of measuring the obstructed length. We'll discuss another method. Select a point T and range R in line of PT. P and Q are 2 points on either side of the pond. But PT is equal to TR. Similarly, range S in line QT such that QT is equal to ST. Measure RS, which gives us PQ. So this is a property of similar triangles where apex is same for two triangles. By using property of similar triangles also, we can measure the obstructed length PQ. This is case 2, where it is not possible to chain around the obstacle. In the previous case, it is possible to measure around the obstacle, but in the case of reverse, it may not be possible to chain around the obstacle because the river width is very long and very long, so we cannot measure across the river. So for that cases, we have to follow this method. A small river comes across a chain line, means this diagram represents a river. That AB is the obstacle. AB is the chain line where P and Q are 2 points on either side of a river. At P, we have to erect a perpendicular PR which is bisected at T, and draw a perpendicular at R which touches S. The point S is so selected on such that S, T and Q are in straight line. S, T, Q should be in a straight line. This can be done by using ranging operation. From triangle PQT and TRS, these two are similar triangles having T as common apex. PQ is equal to RS. PQ is nothing but obstructed length, therefore which is equal to RS. So measure RS, which is on one side of the river, which gives us obstructed length PQ. I again explain because this is something looks something typical for you. It is not that difficult. It is very easy. First, we have to select a point P and Q on both sides of river. Erect a perpendicular at P and divide it into two parts. The center point is marked as T. At R, erect another perpendicular and find out a point S such that S, T, Q should lie in a same line. Means we can do the ranging operation and we can select these 3 points so that these 3 points can be in a single line. By using similar properties of triangles, PQ is equal to RS. So if we measure RS, it will be equal to the obstructed length PQ. In this way, we will measure in case it is not possible to measure around the obstacle. So here, this is another method. In case 2, locate a point R in such a way that it makes 90 degrees with PQ. Range S in a line with PR and makes PS is equal to PR. Let us erect a perpendicular ST to cut the line AB at T. Therefore, here we have created another 2 triangles of which is in similar triangles. By using similar triangle property, we can directly say that PQ obstructed length is equal to PT. We can measure PT means which is we can measure directly the PT value. Therefore, the obstructed length PQ is also be calculated. In this way, we will calculate the obstructed length in the case of chaining obstructed and vision is free. In the next class, we will discuss the remaining methods which are chaining is free and vision is obstructed, like when there is uphill in between 2 points. And the last method, both chaining and vision are obstructed. For example, if there is a building where we cannot do chaining, we cannot observe the points from each other. So these 2 methods will cover in the next class. So in this class, we have covered different obstacles in chain surveying and how to find the obstructed lengths in different cases. First case is chaining is obstructed, vision is free. In this also we have two methods where we can measure around the obstacle and where we cannot measure around the obstacle. In all these in all these problems, we have learned to measure the obstructed length. So for this today, for today's class, I will close the session. We will continue in the next class. We will learn remaining methods of calculating the obstructed lengths. And after that, we will solve some of the problems regarding these methods so that we will get better understanding. Thanks for listening. Thank you.